Alright, on to 7.4. We're going to introduce the idea of logarithms. Okay, so what is a logarithm? What is this thing? I want you to not be intimidated by it at all because it's really a simple idea. Okay, so we'll talk about what a logarithm is, what it means to say the log of something. We're talking about two well-known and widely used logarithms, how to go between logarithmic form, how to go between these two things, and exponential form. They're very closely related, though it wasn't always known that they're closely related. Now we know. Now we realize it at this point in history. And then we'll graph a little bit. Okay? Just a little bit of graphing. Don't be scared. So we're going to find out what is a logarithm. We're going to go between these two forms, and we're going to graph these guys. Okay? So next, first is next. What is a log? So I'm going to use an example first to help you understand what this is. Log base 2 of 8. Right? In order to, when we first started out with math, we would see an equal sign, and it would mean, answer this question, figure out what this is. And it means that again now, at least as we introduce this. Log base 2 of 8. What is that question? What does that mean? And I will explain it using an analogy. Okay, so let's go back to, I don't know, when did you learn multiplication? Maybe 4th grade, 4th or 5th grade. They really started to teach you multiplication. So let's say that they give you a problem like 3 times 4. Okay, so you assume you already knew multiplication, so you were good with that. 3 groups of 4, that's 12. That was easy to conceptualize. We added 3 to itself 4 times, and there you go. And after multiplication came this thing. So we didn't really know what this meant, or maybe it looked like this. Probably it looked more like this, 12 divided by 4. That was harder to understand. What did this mean? What did this mean? What were we trying to do here? So what your teacher probably did at that point, it was to phrase this question in terms of this thing you already knew. 3 times 4 is 12. You knew that. You were solid on that. So to figure out what the answer to this question was, they said, okay, so all you have to think about is 4 times what is 12? 4 times 3 is 12. Right? And that's how you started to think about division. 4 times what is 12? So then you just put it in terms of multiplication. You kind of just went backwards. So that's what we're going to do here. The question that's being asked here, say this is I don't know this yet, okay, log base 2 of 8. This is just as foreign and strange as this appeared to be in the beginning when you first started to learn division, but we're going to make it less foreign and more familiar. We do know already now about exponents. We've done a lot with exponents. So we're going to use exponents to talk about this question. This question right here is the same as the question right now that I'm about to write. It's the same as this question. 2 to the what equals 8? 2 to the what equals 8? Just like we said, 4 times what equals 12, I'm asking you 2 to the what is 8? Well, that's to the 3rd power. 2 to the 3rd is 8. Okay, so 3 goes here, so 3 also goes here. Let's try another one. Log base 5 of 25. 5 to the what equals 25? Maybe we'll put a box here. That way we can just fill it in instead of scribbling it out. 5 to the what is 25. 5 to the 2nd power is 25. So log base 5 of 25 equals 2. This is the identical question to this question. Let's try one more. log base 2, we use 2 again, base 2 of 32. Okay, what's the question being asked here? What do they want to know? They want to know this. What goes right here? 2 to the what is 32? And 2 to the 5th is 32, so log base 2 of 32 is 5. Okay, so when you see log base something of something, that's what's being asked. Okay, so one of the first lessons here that we want to learn, in addition to what a logarithm is, which hopefully we've answered pretty well, is going between logarithmic and exponential form. Okay, so you can see that log base 2 in this form, this is logarithmic form. Log base 2 of 32 equals 5. In exponential form, we take the exact same information and write it in an exponential way. 2 to the 5th equals 32. Just like we could say, oh, we wrote this in multiplicative form, and we wrote this in division form. Okay, the same way in the same way we write this in logarithmic form, or we can write it in exponential form. Same information, written in two different ways. In this example, this is written in the form of multiplying 3 times 4 to get 12. This was written in the form of 12 divided by 4 equals 3. But it's all the same information. Same thing here. All the same information. I'm telling you that that 5 is the power of 2 that gives you 32. 5 is the power of 2 that gives you 32. Exact same information, different way of writing it. Okay? So let's talk about two different logarithms. Okay? You'll notice that with each of the previous problems, I always said log. And first of all, this is how you say these things. Log, let me go back, log base 2 of 8. Log base 5 of 25. Log base 2 of 32. Okay, so it's not log 2, log base 2. It's not log 2 to the 8th. It's not anything other than what I've said before. Log base 2 of 8. Not log base 2 to the 8th, anything like that. Log base 2 of 8. So you'll notice for each of those I said log base something, some kind of a base. You always have to have a base because you always have to ask a question about some number. Okay? The thing that you need to learn and understand and remember is that sometimes you'll see something like this. Log of 1,000. There is no base here. Or at least there's not a base written here. It's just one of those times in math where we try to save ink and we don't write the base. But we all agree, right, as mathematicians, that if there is no base written here, then you just assume a base. Just as a few examples. We could make this any root we want. We can make this the third root, the fourth root, the fifth root of 3. But I haven't written any root here. So what root do I assume is here? Well, I assume, if nothing's written, that it's 2, right? Let's see. Or if I just say e, what power do I just assume e is raised to? Well, I assume it's raised to the first power if nothing's written there. How about if I take 17? I could think of 17 as a fraction. What fraction is 17? Well, I just assume it's over 1. Right? If it's going to interact with any other fractions, I assume it's over 1. So there's just times where we assume things are there without writing them down. Same thing here. What do I assume is written right here? What do I assume the base is? If there's nothing written, you just see log 1,000, you assume that the base is 10. That's called the common log. It's the common base of the log. So let's figure out what this is. What is this? So think about it for a second. The question that's being asked here is 10 to the what equals 1,000. What power do I raise 10 to? What power do I raise 10 to get 1,000? Raise it to the third power. All right. Let's talk about another base. This is called the natural log. Natural log. That's how I always remember it. Okay. Now, that's another thing. It's not IN. It's not 1N. It's LN. It's not NL. It's LN. Right? This is L. We're talking about logarithms. It starts with an L, so this is an L. Logarithm. The natural log. Okay. So the natural log of a number is, let's say I have the natural log of E. Remember, E is just a number. We just learned about E. This is the same as saying, right? We're writing natural log, and I haven't written any base here. So what is the base? It's log base E. Okay? So what is this? What e to the what equals E? Well, just as we talked about over here, I assume that we're raising this to the first power. So what do I raise e to get e to the first? Well, it's only going to make sense to raise it to the first. I can't raise it to the second and get e to the first. I can't raise it to the -5 and get e to the first. It would make sense that these two exponents have to be the exact same thing. So there you go. Log base e of e is 1. What's the power of e that gives me e? That's 1. E to the what is e? That's 1. Okay? So when you see natural log, what I'm teaching you about here is that there are two widely used bases that we're going to use on a regular basis here as far as our work with logarithms, and we don't write the base. The way we convey the base for the common log is I don't write it at all. The log of 10. If you see log of 10, assume that right down here is the number 10. It's log base 10. Of course, this would be 1. If I write the natural log of e to the third, well, that's log base. The base that I am conveying here by writing L and then N is log base e. What is log base e of e to the third? It's going to be, what's the power? E to the what is e to the third? What power do I raise e to get e to the third? Well, of course, that would be 3. E to the third is e to the third. E to the third is e to the third. Right? This 3 is this 3. E to the what is e to the third. E to the third is e to the third. Okay. So those are two bases that we use. We just don't have to say it. Okay? Next, let's see. Okay, so trying to see if in this section, yes, okay. So in this section, we learn about the inverse properties of logarithms, and we'll talk about the inverse properties, and then for the graphing, we'll just do those in the sample problem. So the inverse properties. How about what is the log base 10 of 10 to the fourth? We just looked at this with the natural log base e, and raising e to a power. What's 10 to the what? Right, we're looking for what's in this box. 10 to the what is 10 to the fourth? Well, it's 4. Okay. How about log base 7 of 7 to the third? Okay, we're looking for what's in this box. 7 to the what is equal to 7 to the third? Well, it only makes sense that 7 to the third would be 7 to the third. So this is 3. How about log base e of e to the 5,000? So log base e of e to the 5,000, e to the what is 5,000? Or e to the what is e to the 5,000? Well, it only makes sense that it's 5,000, right? So here's one, property. Log base b of b to the y. The b's kind of cancel. I don't really like that term, but cancel, and that's y. Okay. In the same way, you can verify this yourself. Say a 7 to the log base 7 of 5. The 7 and this log base 7 cancel each other out, and you get 5. Okay? So I'm running short on time. I'll see you in the next video.